So now we're going to do some ray tracing for converging lenses, and here's some converging lenses here. They are wider in the center and skinnier at the edges. Here's another one for you, like this. And so this is going to look very, very, very similar to what we have done before. So I'm going to create an optical axis. And we're going to put a lens kind of somewhere in the middle here, like this. So this is a converging lens. This is my optical axis. And so we're going to have out here, we're going to have a focus. So F is going to be 4 centimeters, and we're going to have another focus. Now these things, mirrors change if you flip them around, but these things do not change if you flip them around. Lenses are symmetric. So lenses are symmetric, so they've got 2 foci. So I'm going to call that focus 1, and I'm going to call that focus 2. And then I'm going to put my person out here. I'm going to say my object is going to be 9 centimeters. And so I'm going to have my little person at 9 centimeters with their little light bulb head. It is the man with the light bulb head. Okay, so we're now going to do it exactly the same way. We have a little ray of light coming from there, parallel to the optical axis, and it is going to go out through the focus, like this. And then we're going to have a ray of light that comes in through the focus and goes out parallel and then we're going to have a ray of light that goes straight through the center of the lens, and if it goes straight through the center of the lens, it is going to just keep going straight. And so I'm going to have my image right there. This is my object. And once again, we even have the same equation. 1 over I plus 1 over O is equal to 1 over F. And so my 1 over I is going to be 1 over F minus 1 over O. And so for 9 and 4, we're going to have 1 over I is equal to 1 over 4 minus 1 over 9. And that means that my I is going to be one divided by 4 minus 1 divided by 9. It's going to be 0.1. Oh, wait, stop. Remember, we have to take the inverse of that number. 7.2. And so I go 1, 2, 3, 4, 5, 6, 7. 7.2 is like right there, and so I'm pretty close. So this is my object is greater than 2f. So my object is greater than 2 times the focal length. Again, we did this one already with mirrors. Okay? And so now let's move them in a little bit. Let's do, well, I'm not going to spend I'm just going to jump right in. I'm going to move them in so that the object is less than for converging convex lens. And I'm going to move them right inside the focus. And so I'm going to give myself a little space because I know what's going to happen with this diagram. I'm going to put my focus right here. Let's see. Yep, I'm going to put my focus right there. So focus is 4 centimeters. And I'm going to put my object here. I'm going to make them kind of small. So my object is 2 centimeters. And there's going to be another focus over here. Oh, I botched this one. I totally botched it. And you'll see why in a second. So I'm actually going to flip this around. I'm going to take him away from there. I'm going to put him over here. So I'm going to work backwards this way to save myself from having to redo this video. And so still this is 4 centimeters, 4 centimeters, and he's at 2 centimeters. And so now we have a ray of light that comes in parallel. And it's hard to work. It's a lot easier to work in mechanical pencil because it doesn't bleed and you get to be a lot more precise. And it goes out through the focus. So that one stays the same. In parallel, out through the focus. Now we're going to go from the top through the center of the lens, and just like I punted on the previous time we did one of these, we have this thing going on where I have to make an imaginary line that would go from the focus to the top of the guy's head. Now the light travels along this way, and when it reaches there, it goes out along a line parallel to the optical axis. And we ask ourselves, where do these three meet? 1, 2, 3. Well, the answer is that they don't meet out here, that they meet virtually back here. So I'm going to revert those back, draw them back, imaginary lines back, because everything is imaginary in virtual land. And then draw that back. And they're going to meet here. Should meet right about there. And so there should be my image